All right, welcome. Today, we are absolutely cracking the code on one of the most rigorous and honestly, sometimes most frustrating topics in the entire Cambridge AS and A-level computer science syllabus. We are talking about monitoring and control systems. Now, we are going to program your brain for absolute efficiency today, giving you the automated patterns you need so you can tackle literally any question the examiners throw your way. If you want to think like a true robot engineer and write your answers like a top-tier scholar, you are in exactly the right place. Let's get right into it. Okay, let's dive into this with a direct quote from the people actually grading your papers. Senior examiners consistently report that monitoring and control systems, specifically the area covering sensors and actuators, is one of the most fundamentally misunderstood areas in the entire computer science curriculum. No joke. So why is that? Why do so many smart students lose easy marks here? Well, because it's not just about memorizing the dictionary definition of a temperature sensor. That's the easy part. It's really about understanding exactly how that sensor interacts within a complex automated system. How does it talk to the microprocessors? How does it trigger the physical actuators? It is a complete interconnected ecosystem. But don't stress, because we are going to fix that misunderstanding right now by showing you exactly what the grading criteria demands. Here's a quick look at our roadmap for today's explainer. First up, we'll look at the exam challenge. Second, unlocking method marks. Third, the deconstruct, solve, evaluate framework. Fourth, top examiner warnings. And finally, we'll wrap up with the success blueprint. Starting with Section 1, the exam challenge. It's time for a paradigm shift.
So what is the absolute classic mistake students make here? It's aiming for what we call superficial breadth. Picture this. You step into the exam hall, you see a question about sensors, and you panic. You just start brain dumping every single fact you've ever learned about sensors and actuators, frantically listing definitions, and just hoping something, anything, sticks to the wall. But here's the reality check. Academic benchmarks at this level demand analytical depth. Examiners do not want a glossary of terms. They want logical, highly structured reasoning. The assessment framework heavily prioritizes how deeply you can analyze a specific system over how broadly you can list vocabulary words. For example, they want to know exactly how an infrared sensor controls a factory sorting line step by step, rather than just reading a generic definition of what infrared means.
So, the crucial point is that mastering this topic requires connecting your foundational conceptual understanding to entirely unfamiliar contexts. The assessment objectives are essentially targeting three distinct cognitive domains. Yes, absolutely, you need knowledge of what a light sensor does. You can't skip the basics. But you also desperately need application, which means using that knowledge in a scenario you've literally never seen before, like an automated greenhouse shading system. And finally, you need analysis. You have to break that specific greenhouse scenario down to explain the exact data flow between the light sensor gathering the data, the microprocessor making the decision, and the actuator executing the physical movement. Before we move on to the actual method to do this, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. All right, moving into Section 2, unlocking method marks. This is your procedural framework. You know, one of the biggest hurdles in monitoring and control systems is that it requires a very specific technical methodology. It's not just theory. It involves heavy, critical data interpretation skills. Examiners are looking for a precise sequence. Step 1, extract from binary representations. Often, a sensor's analog data is converted to digital and fed into a microprocessor in a binary format, right? You have to extract and interpret that raw data accurately. Step 2, perform the calculations based on the control parameters given in the question. And Step 3, draw evidence-based conclusions. Based on your math, does the actuator need to open a pressure valve? Does it need to sound an alarm? Think about the domino effect here. If you rush and misinterpret the binary sequence back in Step 1, your final conclusion about the valve or the alarm in Step 3 is going to be completely, totally wrong. But here is your secret weapon, and it's a real game changer: the method mark strategy. In Cambridge exams, marks are heavily awarded for the process itself and for executing your analysis with crystal clear working. This means systematic processing is your absolute best friend. If you identify the key elements, apply the relevant principles, and verify your results while showing literally every single step on the paper, you secure points. Listen, even if you make a tiny, silly arithmetic error in Step 2 and your final valve pressure answer is slightly off, displaying a systematic sequence guarantees you capture those vital method marks. So, golden rule, never ever do the math just in your head. Write it all out. Section 3, deconstruct, solve, evaluate. Let's look at the critical analysis system.
We call this the Deconstruct, Solve, Evaluate Framework, or DSE. And this brilliantly illustrates how you should approach every single complex, long-form question you encounter. First, you deconstruct. You do this by deliberately identifying the given information in the prompt, like, say, the specific sample rate of an analog-to-digital converter, or ADC. You pull those variables out. Then you solve by breaking the massive problem into logical, bite-sized steps and calculating systematically. Finally, you evaluate. You step back, check your solution for reasonableness, and make heavily justified recommendations on the system's performance. This specific workflow forces you to analyze effectively rather than just guessing or brain dumping.
Now, when examiners explicitly ask you to evaluate algorithm quality in these control systems, you absolutely must address 4 specific pillars. First is time complexity, meaning how fast does the control loop actually execute? Second is space complexity. How much memory is the algorithm eating up on the microprocessor? Third, edge cases. What on earth happens when the sensor receives a totally extreme or unexpected input? And fourth, performance effect. What is the overall impact on the physical, real-world system? If you proactively check off these 4 boxes in your answer, your analysis will be incredibly thorough and dangerously precise. Stop scrolling for just a second. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Okay, let's keep going. Section 4. Top examiner warnings. Let's talk about avoiding the traps. You really want to pay close attention to these 3 major pitfalls because they cost students easy marks every single year. First, students constantly forget to check overflow and edge cases. They just assume the data will always be perfect. Second, they completely ignore boundary conditions. Think about it. If a temperature sensor is programmed to trigger a cooling fan at exactly 100 degrees, what happens at 99.9 degrees? What happens at 100.1? Is it greater than or equal to? You must explicitly define these boundaries in your logic. Third, and this is a big one, providing answers that are not specific to the given context. If the exam question asks you about a nuclear reactor's control system, your written answer better not sound like it's describing a generic smart thermostat in a living room. Context is literally everything. Ground your answer in the scenario they gave you. Treat this next point as an urgent examiner alert, a real study hack straight from the source. Candidates consistently confuse key terminology. You must always define your terms before using them in extended responses. It's so simple, but so effective. Before you launch into some massive multi-paragraph evaluation of a control loop, explicitly define the specific sensors you are talking about. Define the ADC. Define the physical actuators, like the stepper motor that you are analyzing. Taking 30 seconds to do this proves your foundational knowledge right out of the gate and immediately sets a tone of authority with the examiner. Finally, Section 5, the Success Blueprint. Let's put this whole shebang together. Let's move to and see how this builds into your final, foolproof chronological checklist for any practical application question. Step 1, design your algorithms based on the context. Step 2, implement the solutions clearly, showing all your binary and math workings. Step 3, test thoroughly. This is exactly where your boundary and edge case checks come into play. Don't skip it. And step 4, evaluate performance using our 4 pillars of time, space, edge cases, and overall system impact. Consistently following this timeline demonstrates the exact transferable, high-level conceptual understanding that the syllabus demands.
Now, to make sure you don't freeze up when you're actually sitting in that silent exam hall, I highly recommend a simple memory hack. Take the key terms we discussed today, especially that deconstruct, solve, evaluate framework, and create your own funny or memorable mnemonic using the first letters. Write that phrase at the top of your scratch paper the literal second the exam begins. Having that visual mental trigger completely automates your problem-solving pattern. It takes the pressure off your working memory, letting you save all your brain power for the actual complex analysis of the sensors and actuators.
So, I want to leave you with this final, critical question to chew on. When you sit down to write your next past paper answer, will it be generic or will it be highly specific to the context given? Will you rely on superficial breadth or will you showcase analytical depth? The choice is entirely yours, but you now have the exact blueprint to succeed. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to at acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. AC Exams, your Cambridge success starts here.